morning, everyone. I will continue Schaub's talk about the density function, and after with the definition and example, and after that I will talk about the continuous joint density function. Okay, the first definition is if x, then we have y then we can say fx x, then we know y is equal to x or with an entry. We can say f xy equal to jx and hy. Then random variable x and y are independent. When random variable of x and y are independent, we can write this equation or equivalently this equation. It means that x it does not depend on the y. So not if we can find n x and y for which f x and y is not equal to jx hy, then x and y are not say that when x and y are independent, we have this equation. Then, if you find that the fxy is not equal to jx and hy, it means that x and y are not independent. It means that they are dependent to each other. X dependent to y or y dependent to x. Also, if x and y we have some properties such as f bar, then we have x equal to h bar, f x when we know the by or we receive the by, x and f x y equal to x h y. Similar to this that we mentioned is if we say that the x and y are independent, we have to have these properties. And this is an example here. Okay. Assume that we have a binary communication channel. Okay, we have a table like this. Zero, one, zero, one. X zero, and when x is zero or when x is one, and here by you have jx here and h1 here. Okay, we have this values for the table. For the 1, when x is equal to 1, 0.03, 0.47, 0.5 here, and here we have 0.48 and 0.52. Okay, we know these values. Then we can easily say that x and y are not independent because say that x and y are not independent because we have to show these properties for this. But for example, here you can say f0, 0 is not equal to j0 multiplied h0. Okay? Means that we have 0.45 for f00. It means we have this value for here, and for jx and hy we have this value is 0.5 for jx and multiple 0.48. And we know that these sides, the right side and left side is not equal. Then we can say x and y are not independent because we can't prove this. We can't show this property. Another example is don't write it here because it's not visible in the camera. I will continue here. Okay. Another example. So this is two plus 4 x and y. Okay. X and y are independent because here we said that if x and y are independent, we have to show these properties. Then, for example, for the first one, we can say f xy is equal to jx hy for every single x and y. Okay. Also, note that in this case we can write it like this: f y when we know x is equal to fxy or gx. We know that the fxy is 1/36 because we have 2 dice roll, and jx is 1/6. Okay, means that we have 1/6 that is equal to h by. Then we know that the jx is equal to 1/6, hy is equal to 1/6. If we multiply these values together, we can find the fxy. It means that we can easily show that the fxy is equal to jx multiplied by hy. And okay, you can say for every single x and Okay. Similarly, we can say fx x when we know y is equal to fxy h y. Then we have 1 over 6, 1 over 6 is equal to 1 over 6. This is equal to gx. Okay, now we can say these three showing one of these three conditions is enough to prove the independence of x and y. Okay, we just need to show one of these three conditions to show the independency of the x and y. Okay, it's just an example about the condition properties. The next topic that I'd like to talk about is continuous joint density function. Okay. You continue or type with continuous joint density function. Okay. First, we have a definition for continuous joint density function. Joint density function of f x and y of the continuous random variable of x and y. Okay, we have two properties. The first is a fx y less than 0 for all x, for all value of the x and y, fx and y have to be greater than or equal to 0. Okay? Second property is integral minus infinity to infinity, double integral, infinity to infinity, fx, y, dx, dy is equal to 1. Okay. For continuous John density function, we have to know this condition. First, for the R value of the x and y, we have the fx and y has to be greater than or equal to 0, and double integral of the x and y has to be equal to 1. Okay. Then also for any region A in the x and y plane, we have this probability of x and y when are belonging to the region of A is equal to double integral in the range of A, because it's in the region of A. Okay? Fx, y, dx, and dy. Okay? When we are in the region of A, we can use this condition instead of minus infinity to infinity, or integral is in the range of the A, that is our region. Okay? I will show you an example to better understand this definition. Example. Okay. Then f x and y shaped like a cone. Okay. When fx and y shape like cone, we have a shape like this. If you consider this as a scale of x, okay, okay, I think you draw the shape minus 2, 0. Okay. Assume here is 0, 2, and here 0 and minus 2. the x-axis we have this value, in the y-axis we have this value, and we have the z-axis we have h, the value of the h. Okay, let me draw it. Okay, if you consider this shape as a cone, I know that's not exactly, but we can assume that's as a cone. Okay, we have a value here because you know that is the z-axis. Z. Okay, then we have these properties for this shape. You can say fx, y is equal to h minus x2 plus y2 r2, then x2 plus y2 is less than or equal to 2, and we have 0 as that. Okay, we have property for this shape. Find h that makes f, x, and y a valid density. Okay. We know that this integral minus infinity to infinity minus infinity to infinity fx by dx dy is equal to volume under we know that if you find this integral, double integral, then we can find the volume on the cone, because we say that if it's in the region of A, we can find that value. Okay. Okay, for find the volume under the cone, it will be better that we find area at first. We find the area at z, then we can say okay, 0 to h, area of circle at I, Z. Okay? Yes. Okay, if you want to find it, we have to make a circle around the point of Z like this. Let me put the road. Okay, we have to find this area first. Okay, we can easily write it equal to 0 to h 4p h minus z is equal to h2 dz. Let me describe this, how we can find it. You know that it's not exactly, but you know this in Python in your high school, but I will describe it a little bit. You know that for this we have R or Z. The R is the radius. Then we can write h minus z h, because you know if we draw a triangle or a scale here, okay, then we can say it's like a triangle when we have this border. We can say it's the triangle, then we can find the radius here, or we can say similar triangle. Okay, we can draw it. Okay. We show that we can draw a line here, then we have a triangle like this. Okay, then R is here, H is here, Z is here, then we have H minus Z here, then we can say that this radius of circle height of Z. Okay, but it's not related to this course, just for your information. You can find it this like this. Then we can find this like this. Volume is equal to, you know that's the constant. We can put it behind the integral 4p h2, because we just have dz here. We can move the constant out of the integral. Okay, 0 to h. Then for this, we can write h2 minus 2hz plus 2 z. Z2. Okay. Dz. Then it's equal to 4p h2 z 0 and h minus h z2 0 and h plus z3 3 0 and h. And the type property, you know that we can write this like this: 0 and h h2 minus 0 and h 2z plus 0 and h z here. However, you know this, then we directly can write this one. Then we can write 4p h2 h3 minus h3 plus h2 3, okay, is equal to 4 pi h over 3. Okay, we said that before. We said that we have a condition like this. You remember? Minus infinity to infinity, infinity to minus infinity, fx by dx dy equal to 1. We said this property. No, we know that the volume, since volume is equal to 1, then we can write, we know that we find the volume here, this value, we can write 4